So, what if our digital world wasn't just a bunch of flat files and holders, but a physical space you could actually walk through? What if an AI's memory wasn't some abstract thing in the cloud, but a tangible place you could explore right alongside it? Well, today we're going to dive into a project that's not just asking these questions, it's building the answers. This is Knowledge 3D. So, this quote right here. This is what an AI collaborator actually said to the creator of the Knowledge 3D project. And that one sentence, it just gets right to the heart of this entire story. It's not about stuffing an AI with more data. It's about giving it, and us, an entirely new reality to understand that data in. So, what's the core vision here? It's a really fundamental shift in how we interact with information. We have to forget about files and folders for a second and start thinking of software as a space, a shared, navigable universe that we can all explore together. And this is where it gets really mind-bending. Just look at the comparison. Right now, our reality is flat files inside folders. We click through windows. We talk to our AIs through what's basically a command line. The K3D vision flips that whole concept on its head. Your computer becomes a 3D world, like a house you can walk through. Applications, they're not just windows anymore, they're entire rooms, each designed for a specific task. And maybe most importantly, the AI is no longer a text box. It's an embodied presence, an avatar, sharing that same exact space right there with you. Now, a vision this big, this ambitious, well, it's gonna need a pretty unique team, right? And the team behind Knowledge 3D is about as unconventional as it gets. Let's take a look at the architect and what they call the swarm that's building this new reality. So you've got the visionary, the architect of this whole thing, and get this. He's a self-described, no-coder human from Brazil who just has this incredible innate gift for systems architecture. He provides the high-level vision, the why and the what. And his development team, it's a swarm of AIs. Codex, Kimi, GLM, you name it. They take that vision and they handle all of the how. They manage the project, they write the code, they debug the system. It's this perfect symbiosis of human vision and machine execution. And that's why this whole model is so powerful. It's just brilliant. The AI swarm is the ultimate meritocracy. It doesn't care who you are or where you're from. It only evaluates your ideas based on their logical coherence and their potential. It creates this direct path from a powerful idea straight to a functional reality, completely bypassing all the traditional gatekeepers. Okay, but a vision like this is one thing. Making it real, that's something else entirely. For K3D, the key, the big breakthrough, came from a completely counterintuitive insight, one that really challenges a core assumption about how we've been building AI. For the last few years, the entire industry has been chanting one mantra: bigger is better. More parameters, more data, bigger models. But this project was inspired by research that asked a very, very different question. And the answer came from this concept called tiny recursion models, or TRM. The idea is simple, but it's absolutely revolutionary. Instead of a huge, sprawling network, you use a very small, very simple network, and you have it loop or recurse on a problem over and over again. It's kind of like giving a really smart person one simple tool and just letting them use it repeatedly to solve an incredibly complex puzzle. And the results, honestly, they're just stunning. Look at this study from the TRM paper. They tested models on these extremely difficult Sudoku puzzles with very little training data. The large 16-layer model, it actually performed the worst. The medium one did a bit better, but the tiny 2-layer model, the one with the fewest parameters by far, it achieved the highest accuracy. So here's the crucial point. When data is scarce, this deep recursion in a tiny model can bypass what's called overfitting. That's when a model just memorizes its training data instead of learning to generalize, and it achieves much, much better results. Less is more. It's so simple, right? But that one idea, that became the rock-solid technical foundation for everything in Knowledge 3D. And as you're about to see, it's exactly how they're able to build an entire universe on hardware that can fit right on your desk. So, okay, how do you take this less is more philosophy and actually use it to build a massive 3D universe for knowledge? Let's get into the practical magic here. Okay, first up, they developed something they call the dual texture paradigm. Sounds complex, but it's a super clever idea. In the K3D world, every single object, let's say it's a book on a shelf, it has two textures. You, the human, you see a beautiful, high-resolution book cover, but the AI sees a second compressed texture that's packed with data it can understand. This lets both human and AI look at the exact same object and perceive it in their own native language, all inside the same shared space.
All right, now let's talk about performance. Because the core K3D model is so tiny, you can run hundreds of them at the same time on a single consumer GPU. So let's compare the old way of doing things, processing, say, 500 complex questions one by one, with the new K3D way of processing them all in parallel.
The old way, processing these questions sequentially, would take about 50 minutes. Respectable, sure, but just watch this. The K3D way, by running 128 of these tiny models in parallel, processes the exact same 500 questions in just 24 seconds. I mean, that's not an improvement. That is a complete change in what is even possible. We're talking a 125-fold speed up. It's a total game changer. And this slide right here, this shows us exactly why. The K3D model, with its 2.1 million parameters, needs only 8.4 megabytes of video RAM. Now, compare that to standard models like Llama 2 or Mistral, which need 28 gigabytes. They can't even fit once on a standard 8 gig consumer GPU. You could fit over 950 instances of the K3D model on that same graphics card. This isn't just efficient, it's democratic. It makes this kind of power accessible to everyone. So all this radical efficiency, it isn't just a cool technical achievement. It's the engine that literally turns this house of knowledge into an entire world. It's the key to an entirely new future for how we think and create together. Because the key thing to remember here is that what's been built isn't just a theory. It's exactly what this says, a complete, functional, closed-loop, cognitive architecture. It's a new kind of operating system for the mind, where human intuition and AI processing can just flow into one another seamlessly and endlessly. And that brings us to this final, really profound takeaway. By grounding data in a physical, navigable space, the project completely transforms our relationship with it. It's no longer just an abstract network of links and nodes, it's a world, and it's just waiting to be explored. And I guess the question it leaves all of us with is, what are we going to discover inside?